Hi everybody, welcome to another video in Math 1324, section 4.4, matrices, basic operations. So in this section we study about some very basic operation of matrices. But first we need to define what is a matrix. So matrix is a two-dimensional array, so pretty much a table of numbers. It has row and columns. And each entry each number is called an entry of the matrix, or we call an element of the matrix. And when we denote Aij like this, we mean that in the row I and column J. So when we have this, that means it is on the first row on the second column. And because of that, we look at the last entry here. This is m rows, and n column. So this matrix have m rows and n column, right? So this matrix has m rows and n column based on the last entry, and we call the order or the size of the matrix is m by n. Right. So when we write 8, 1, 2, we know for sure it is on the first row, second column. However, if we want 1, 2, 3, that is confusing. We don't know if it is on the first row, 23rd column, or 12th row, 3rd column. So in that case, we may want to put a comma there too. So it's clear, it's no long confusing. But usually if it is just one number for row, one number for column, then we know for sure. We don't have to write the comma. Two matrices are the same if they have the same order, meaning the same number of rows and columns, and the corresponding elements are equal. So very basic. Next, how do we add or subtract matrices? Right, so when we add or subtract, first of all they have to have the same order. So both of these has 2 rows, 3 columns, so we can add them. And then we just add or subtract the corresponding entry. So the first row, first column with the first row, first column, like that. So I will say a plus b 1, 2, negative 3, 4, negative 1, 0, then add 0, negative 2 and 3, 4, 2 and 1. Then we combine the entry first row, first column with first row, first column. Same thing here. Remember, in the matrix we just have the space in between, and we don't write a comma in between the entries. Right. That gives us 1, 0, 0, 8, 1, and 1. Right. And when we subtract, just subtract the corresponding entry. So we subtract the corresponding entry. So if we use the calculator, alpha and zoom, and now this one has 2 rows, 3 columns. So just have 1, 2. The negative is here, not subtract. And then subtract. Zero, -2, 3, 4, 2, and 1. So that's when we subtract. Oh, 2, that will be 4, sorry. Yeah, 2, so that plus, so yeah, that's what we have. Of course, just if you want to add, do same thing. Set the plus in the middle. Yeah, so that's what we have. So just add or subtract the corresponding entry of this file. Next, we multiply. The first multiplication is multiply by a number. So a scalar is a number. If a number is multiplied to the matrix, then we take that number multiplied to every entry. So multiply that into every element of the matrix. So let's say we have -5b. This is b. So -5b. And we'll take that -5, we multiply to everything inside. Give us -10, 15, -25, and 30. Next, 2 times this matrix plus 3 times that matrix. So multiply the 2 inside. Now our space, so just multiply 2 inside, so that gives us -2, 8, 2 times 2 is 6, 2 times 0 is 0. So multiply, divide, and then add or subtract. So multiply first, and then multiply first. 6, -9, 15, and -18. And now we add them. -2 plus 6, that's 4. 8 plus -9, -1. 6 and 15, 21, 0 and -18. Right. So let's check. If we have 2 times alpha zoom, this is the 2 by 2. Right. Matrix 8, -1, 4, 3, and 0, and then plus 3, 2, 2, -3, 5, and -6. Right, so that's what we have. Right. Next, we will solve for the matrix X in this form. So to solve for that, we will solve for the matrix form first. Minus a on both sides here. So give us 2x equal to b minus a. And then divide by 2 on both sides. So we cannot divide 2 in the matrix, but we can multiply by 1/2. So we have x equal to 1/2. Multiply 1/2 on both sides. B minus a. So we have 1/2. The matrix B minus matrix A. Now we subtract first inside the parentheses first. 2 minus -1 to 2 plus 1, 3. -3 minus -4, so that's -7. Five minus 3 is 2. And minus 6 minus 0. And then we multiply 1/2. So 1/2 times 3 would be 3/2. 1/2 times -7. -7/2. 2 or times 1/2 is 1. -6 times 1/2 is -3. So that's what we have. So that's just regular. I will multiply a number into the matrix. Now the more complicated thing is I'll multiply a matrix into the matrix. So that requires a little bit more. So whatever you do not multiply the corresponding entries because there might not be a corresponding. So we cannot do that. So what we do before we do multiplication, we have to check the dimension. So if A is m by n and B is n by p, then the matrix A times B is defined as the m by p matrix. So when we multiply, the middle numbers have to be the same. In that case, the outside number will give us the dimension of the product. Alright, let me say that again. So what we need is the middle dimension have to be the same. This have to be the same. So in which case, the outside number will give the dimension of the product. So it will be m by p. Right now, after we check the dimension, if it works, what we do is in the product of I row and j, we will take the row from the first matrix, column from the second matrix, multiply 1 by 1, and then we add all of them up. So it will be the sum of the product. I row of A and j column of B. Right, so I'll take A times B. A times B. Let's check the dimension. 2 by 3, 2 row, 3 column. And B is 2 by 2. So first thing we do, of course, we will check the middle number. And here we don't have the same. So not the same. So in that case, we say AB does not exist because the dimension here does not match. So we just hide that. Right. Now let's check the other way around. B times 8. B is 1, 4, 0, negative 1. Now times this matrix. So now let's check the dimension. First, this one is a 2 by 2 and this is the 2 by 3. The middle dimension are the same. So we will have the outside as the dimension of the product. Now, and the next, so this is going to be 2 by 3 at the end, right? Now, what we do is just say whatever the entry here, let's say this is on the first row and first column, right? First row, first column for the product, first row and first column. The first row comes from the matrix 1 and first column. So the row comes from the first matrix, column comes from the second. And after that, we take the product of 1 times 2, then 4 times 0. And we add the products. 1 times 2 plus 4 times 0. 1 times 2 is 2. Right, next. Row times column. So 1 times negative 1 plus 4 times 2. So that negative 1 and 8 give us 7. This on the first, this one. First row, third column. First row, third column. 1 times 3 plus 4 times 1. And to that 3 and 4, that also 7. Right. We don't have to follow the order of things. We just try randomly. Let's say if we want, say this one. So that is on the second row, second column. So we just use second row and second column. Negative 1 times 0, 0, negative 2. Yeah, so just check a row times a column will give us that row and that column in this matrix. So row times column. 0 times 2 is 0, negative 1 times 0 is 0. And then that's last one, row times column. Second row times third column, 0 times 3, negative 1 times 1. So that is negative 1. Right. Let's see how it works. On the calculator, alpha zoom. 2 by 2. So that's what we have. So make sure the dimension match. In that case, row times a column, that would be the corresponding, like this one, this row and this column has the same number of entries, so we can multiply like that. So let's look at the application. Suppose a company that make two types of skis that require lapse hours, labor hours. So we have trick ski and slalom, assembly and finish. And then suppose that the company has two manufacturing plants, California and Maryland. And the following rate, we have that. Find A and B and interpret the product. So of course both of them are 2 by 2. So if it's 2 by 2 times a 2 by 2, so we can take this matrix times this matrix or that matrix times that matrix. Because 2 by 2 times 2 by 2, we can multiply it either way. Right. One important thing is that we need to know that is A times B is different than B times A. The order of when we multiply the product cannot be swapped. Right. So in this case, it said let's A times B. Let's see what is the meaning of that. So we just take A times B. So AB. I'm just going to give them space here. 5, 1.5, 3, and 1. Then times B, 12, 8, 12.5, and 7. Right, so row times column, right? Check dimension real quick. 2 by 2, 2 by 2. So the product is going to be a 2 by 2 matrix. Right, so just multiply first and then we interpret the result later. So row times column. If we take the first row times the first column, first row first column, so we're going to have the first row first column entry 5 times 12 plus 1.5 times 8. I'm just going to use this 5 times 12 plus 1.5 times 8. That gives us 72. And then first row second column, give us first row second column. $73. Go to second row, first column. At 44. And then 3 times 12.5. Plus 1 times 7, or just 7. 44.5. Right, so we multiply. So what is the result? Now let's check. Originally, this is a trick ski and slalom. And that gives us assembly. And finish. And this is assembly and finish for California and Maryland. So when we multiply this, the category for assembly and finish have to match with assembly and finish. So that makes sense. If we multiply the other way around, it would not make sense. So have to match like that. So at the end, we will start with this. The part that are the same we cancel out. just like when we multiply middle dimension almost cancel out, and we have, of course not cancel, but they have to be the same, so the outside will be the dimension of the product. And just like this, the middle will cancel out. Oh, assembly, finish. So we just have the Twix key at California, and the Twix key at Maryland, and the Slalom key. Right. So we say that the Twix key, if it all produced at California, the cost is going to be 72, and the Twix key produced at Maryland will be 73. Assembly and finish. So let's say assembly and finish kind of simplified out, kind of, but of course not cancel in a sense. So for example, if we take just pick one, that if we take this row times this column, so that means we have a Twix key that takes out 5 hours to assembly. At the rate of 12, I assume 12 hours a dollar, $12 an hour. That's the rate, and then plus need 1.5 hours to finish, and the rate is 8. So that gives us the cost to produce a Twix key in California. Right, so of course that, like I said, if you multiply the other way around, it will not make sense. This have to match with this. Right, next. In a certain state, legislature, percentage of legislators voting for or against lowering legal drinking age by various party affiliation is summarized as this. There are 60 Democrat, 30 Republican, and 10 Independent. Use a matrix calculation to see how many legislators vote for lowering the drinking age and how many vote against it. So we have a matrix here, and then we have another matrix. So this is a 2 by 3. So what do we multiply by? So if we multiply by the matrix, next one we have 60, 30, and 10. So this of course we're going to put in the matrix. But if we put in like 60, 30, and 10 like that, we cannot put on the back here because this is 1 by 3. If we have a 1 by 3, we have to put that in front. If we have 3 by 1, we can put on the back. So we're going to have 1 by 3 like this. So in this case, the matrix have to be, let's start with this A matrix first. So let's just say it, Democrat, Republican, Independent, and then this is for and against. Sorry, that is not the matrix I want to. Okay, so we should have, it's now this line, so we should have 60, 30, and 10. So we have Democrat, Republican, and Independent. So when we multiply like this, row 10 times a column, row times a column, so that makes sense, right? So check the dimension. This will have a 1 by 3, 3 by 2. When we multiply, we have the 1 by 2. And for that, So this and this category match and almost cancel. That we have 1 by 2. At the end we just have 4, and against we just multiply row times column, or I just say, yeah, just use the calculator here. It's simple enough. 1 row 3 column. And then 3 rows 2 column. At 55 and 45. So out of this 100 people, 55 will vote for and 45 will vote against. That including all the different parties affiliation. Right? So that's how we multiply matrices. Take a row times a column, row times a column. Like 60 times 0.6, 30 times 0.3, and 10 times 1. Add all of them up, we should have 55. Right, so with that we finish section 4.1. 4.4, sorry. Thank you for watching, and see you in another video in Math 1324.